To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Thevenin's theorem. Question. Find the current through 30 ohm resistor. In this circuit, we have to find the current through this 30 ohm by using Thevenin's theorem. Solution. First of all, let's redraw the circuit. Thevenin's theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a voltage source VTH. So let's draw VTH. This is VTH. In series with a resistor RTH. Here VTH is the open circuit voltage at the terminals and RTH is the equivalent resistance at the terminals when all the independent sources are turned off. And this is RL and this is IL. IL is equal to VTH upon RTH plus RL. Now here, let's solve this. Here we can see the RL value is, here we can write RL is equal to 30 ohm. So again, let's copy this circuit from here. And here we can write to find RTH. Let's remove this. And this is RTH. Now to find the value of RTH, turn off all other sources. Turn off all other sources. Now when we turn off voltage source, that time it will be short circuited. So it will be short circuited and this will be short circuited here. So here RTH is equal to 20 ohm parallel with 10 ohm. 20 ohm parallel with 10 ohm. 20 multiplied by 10 divided by 20 plus 10. 20 multiplied by 10 divided by 20 plus 10. So it is 6.6. 6.6 is the value of RTH. Now, next we have to find the value of VTH. This is called as Thevenin equivalent circuit. This is Thevenin's equivalent circuit. So to find VTH, let's copy this circuit from here. And this will be VTH. This is plus, this is minus. Let's say this is current I1 and this is current I2. And let's say this is current I, total current I. Now let's find the value of this current I. So apply KVL to the outer loop. Now according to the direction of this current, this will be positive, negative, positive, negative. So here we start from this point, so it will be minus 20, then this will be 20 plus 10, this will be 30I, so plus 30I, then plus 10 is equal to 0. So we can find the value of this I. This will be minus 20 and this 10 will be 30I and plus 10 is equal to 0. Now this will be, now here this will be minus 10, minus 20 plus 10 will be minus 10 is equal to 0. 30I is equal to 10. So I is equal to 10 divided by 30. 10 divided by 30. So it will be 1 by 3 and we can write I is equal to 1 by 3 is 0.33 ampere is the value of current I. Now here this I is equal to I1. So let's apply KVL to mesh number 1. Here we can write apply KVL to mesh 1. Let's say we are starting from this point again. So it will be minus 20, then plus 20 I1, then plus VTH is equal to 0. Plus VTH is equal to 0. Now here this I1 is equal to I. The value of I is 0.33. So here we can write 0.33. So it will be minus 20 plus 20 in bracket 0.33 plus VTH is equal to 0. Now if we solve this, so we get minus 20 plus 20 in bracket 0.33. So it is minus 13.4. Minus 13.4 plus VTH is equal to 0. So VTH is equal to 13.4 volt. So this is the value of VTH. Now we got the value of VTH and we also got the value of RTH. Here this is the value of RTH. So we can draw Thevenin equivalent circuit. So let's copy this circuit from here directly and substitute the value of VTH. It is 13.4. So 13.4 volt. The value of RTH is 6.6 ohm. So it is 6.6 ohm and the value of RL. The value of RL is 30 ohm. So this will be of 30 ohm. Now let's solve this or directly substitute the value of this VTH, RTH and RL. So here we can write IL is equal to VTH is 13.4 divided by RTH is 6.6. 6.6 plus RL. RL is 30 ohm. So if we solve this, we get the value of RL 13.4 divided by 6.6 plus 30. So it is 0.36. 0.36 ampere is the value of IL. That is the current through 30 ohm. So here we can write IL is equal to I 30 ohm is equal to 0.36 ampere. So this is how we can find the current by using Thevenin's theorem. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Thanks for watching. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Thevenin's theorem. Question. Find current through 8 ohm resistance by using Thevenin's theorem. Solution. First of all, we will see what is Thevenin's theorem. Thevenin's theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a voltage source VTH in series with a resistor RTH, where VTH is the open circuit voltage at the terminals and RTH is the equivalent resistance at the terminals when all the independent sources are turned off. So this is VTH and this is RTH and this is the load resistor RL. This is load resistor RL and this will be load current IL. Now to get the value of IL is equal to VTH divided by RTH plus RL. Now let's see the question. So this is the question and we have to find this current. The current through this 8 ohm resistance. So first of all, let's find the value of RTH. So to find RTH, turn off all independent sources. Turn off all independent sources. Now let's turn off all the independent sources. So this will be turned off and this will be turned off. So we will short circuit them because they are the voltage source. When we turn off a voltage source, that time it will be short circuit. And then we have to remove this load resistor RL and now this will be our RTH. Here we can write the value of RL is 8 ohm. Now let's find the value of RTH. Here we can clearly see that this 6 ohm and this 10 ohm are connected in parallel. So 6 ohm, or we can write RTH is equal to 6 ohm parallel with 10 ohm. So it will be 6 multiplied by 10 divided by 6 plus 10. 6 into 10 divided by 6 plus 10. So it is 3.75 ohm. 3.75 ohm is the value of RTH. Now we got the value of RTH and let's write the value of RL also. The value of RL is 8 ohm. It is a load resistor. Now next we need to find the value of VTH. So let's find VTH. To find VTH, just we need to remove RL. Now if we remove RL from here, so this will be our VTH. So here this will be VTH, this will be positive and this will be negative. Now let's say the current flowing through this circuit is current I. This is current I. So let's apply KVL to the outer loop. First we will apply KVL to the outer loop. After that we will apply KVL to this mesh. Let's say this is mesh number 1 with current I1. So first of all let's apply KVL to outer loop of circuit. So let's say we are starting from this point, so it will be minus 20, then this will be 6 plus 10, 16i, so plus 16i, then plus 12 is equal to 0, plus 12 is equal to 0. Now we can easily find the value of current I. This minus 20 and this 12 will be minus 8. So 16i minus 8 is equal to 0. So therefore 16i is equal to 8 and I is equal to 8 by 16. So 8 by 16, that means I is equal to 1 by 2. So 1 by 2 means 0.5 ampere is the value of current I. Now here this current I is equal to I1. So let's apply KVL to mesh 1. Apply KVL to, let's say, loop 1, loop number 1 or mesh. So let's say we are starting from this point again, so it will be minus 20, then plus, this will be plus, this will be minus, so plus 6i1 plus 6i1, then plus VTH is equal to 0, plus VTH is equal to 0. Now we got the value of I is equal to I1. So therefore here we can write I is equal to I1. So therefore I1 is equal to 0.5 ampere. So let's substitute this value 0.5 ampere here. So it will be minus 20 plus 6 into 0.5, then plus VTH is equal to 0. So let's solve this. So it will be minus 20, then plus 6 multiplied by 0.5, minus 20 plus 6 multiplied by 0.5, so it is minus 17. Minus 17 plus VTH is equal to 0. So therefore VTH is equal to 17 volts. Now we got the value of VTH and RTH and RL. So we can draw this Thevenin equivalent circuit. This is called as Thevenin equivalent circuit. Here we can write it is Thevenin's equivalent circuit. Let's copy this from here and let's paste it here. Now we will write the value of VTH. It is 17 volt. The value of RTH is 3.75 ohm. The value of RL is 8 ohm. So it will be of 8 ohm. Now we can easily find the value of this IL, that is the current through this 8 ohm. So it will be VTH value is 17 divided by RTH value is 3.75, then plus RL value is 8 ohm. So therefore IL is equal to, this will be 17 divided by 3.75 plus 8. So it is 1.44 ampere is the value of IL. So therefore IL is equal to 1.44 ampere, but IL is equal to I8 ohm. So therefore I8 ohm, the current through 8 ohm will be 1.44 ampere. So this is how we can find the value of current by using Thevenin's theorem. This is what we have to find, the current through this 8 ohm by using Thevenin's theorem. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Thanks for watching. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Thevenin's theorem. Question: find the current through 2 ohm. Here in this circuit, we have to find the current through this 2 ohm resistance by using Thevenin's theorem. Solution: first of all, we will see what is Thevenin's theorem. Thevenin's theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a voltage source VTH in series with resistor RTH. Where VTH is the open circuit voltage at the terminals and RTH is the equivalent resistance at the terminals when all the independent sources are turned off. This RL is the load resistor and this IL is the load current. IL is equal to VTH divided by RTH plus RL. Here this circuit is called as Thevenin's equivalent circuit. This is called as Thevenin's equivalent circuit. Now, first of all, let's find the value of RTH. So, step number 1, to find RTH, remove RL. Now, what is RL? Here we can see we have to find the current through 2 ohm resistance. That means 2 ohm is the value of RL. So, here we can write RL is equal to 2 ohm. So, to find RTH, remove RL and turn off all independent sources. Now, when we remove this RL and turn off all the independent sources, here we can see this is an independent voltage source. When we turn off independent voltage source, that time it will be short circuited. And when we turn off independent current source, that time it will be open circuited. So, this will be open circuited, and now this will be our RTH. Now, here we can see this resistor is open circuited. So, we can remove this from here, and now this will be our RTH. So, here we can see this 4 ohm is in series with these two parallel resistors. So, therefore, RTH is equal to 4 plus 5 into 6 divided by 5 plus 6. So, this will be 4 plus 5 into 6 divided by 5 plus 6. So, it is 6.72. 6.72 ohm is the value of RTH. 6.72 ohm. Now, next we have to find the value of this VTH, that is Thevenin's voltage. So, step number 2. Step number 2, to find VTH, again remove RL and VOC, that is open circuit voltage, is equal to VTH. So, here again what we will do, we will remove this RL, and now this will be the open circuit voltage, or directly we can say it is the VTH. So, this will be positive here and negative here. Now, we have to find this VTH. So, first of all, this current, the current through this is 6 ampere. Here we can see this current is 6 ampere, and here we have to find this current. Let's say this current is current I1. Now, we will find the value of I1. So, I1 is equal to V by R, voltage divided by resistance. The value of voltage is 24 and the value of resistance is 6 plus 5. 6 plus 5. So, this will be 24 divided by 6 plus 5. So, it is 2.18. 2.18 ampere is the value of I1. Now, here let's assume this is also a mesh. Let's say this is current I2. So, what we will do, we will apply KCL. Not KCL, we will apply KVL. Apply KVL, that is Kirchhoff's voltage law, at mesh 2. Let's say this is mesh number 2. Apply KVL at mesh 2. So, according to the direction of this current, this will be positive here, negative here, positive and negative. Now let's say we are starting from this point. Let's say we are starting from this point. So it will be plus 4. So plus 4, and here this will be I2 plus 6, because both the directions are same. So it will be I2 plus 6, and this 4 ohm is common in both I2 and this 6 ampere. So it will be like this, I2 plus 6, then plus 5 plus 5, and here this will be I2 minus I1, because the direction is opposite. This is upward and this is going downward. So it will be 5 in bracket I2 minus I1. I2 minus I1, then minus VTH is equal to 0. Minus VTH is equal to 0. So from this we can simplify this. So it will be 4I2 plus 4I2 plus 6, 4 into 6, then plus 5I2 minus 5I1 is equal to VTH. Now we also have the value for this I1. I1 is equal to 2.18. So let's substitute I1 is equal to 2.18. So it will be 4I2 plus 4 into 6 plus 5I2. We can further simplify this, like 4 plus 5, it will be 9I2, and this will be 24, and this will be minus 5 into I1 value is 2.18. So 2.18 is equal to VTH. Now here we can see this current, this circuit is open circuited. This is open circuited. So this I2 value will be 0. So here we can substitute, since the loop is open circuit, so therefore I2 is equal to 0. Now this will be 24 minus 5 into 2.18 is equal to VTH. 24 minus 5 into 2.18 is equal to VTH. So therefore VTH is equal to 24 minus 5 multiplied by 2.18. So it will be 13.1. 13.1, and since it is a voltage, so its unit will be volts. So this is the value of VTH. Now we got the value of VTH and RTH, so we can draw Thevenin's equivalent circuit. Now from here, if we copy this from here, the value of VTH is 13.1 volt, and the value of RTH, it is 6.72 ohm. 6.72 ohm, and the value of RL is 2 ohm. We have to find the value of IL. So if we substitute VTH, it is 13.1 divided by RTH. The value of RTH is 6.72 plus the value of RL is 2 ohm. So therefore it is equal to 13.1 divided by 6.72 plus 2. So it is 1.50. 1.50 ampere is the value of IL. That is the current through 2 ohm. IL is equal to, this IL is equal to the current through 2 ohm. So it is equal to 1.50 ampere. So this is how we can find the value of current by using Thevenin's theorem. To get the free notes of circuit analysis or electrical circuits or network analysis, check the link in the comment section and install the app for free. Thanks for watching. To get the free electrical engineering dictionary app, check the link in the comment section and install the app for free. Thevenin's theorem. Question. Find the value of current I by using Thevenin's theorem. Here in this circuit, we have to find the value of this current I by using Thevenin's theorem. First of all, let's copy this circuit. Now let's see the statement of Thevenin's theorem. Thevenin's theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a voltage source VTH in series with a resistor RTH. Where VTH is the open circuit voltage at the terminals and RTH is the equivalent resistance at the terminals when all the independent sources are turned off. And this is the load resistor RL. And this is load current IL. And here we can write IL is equal to VTH upon RTH plus RL. And this circuit is called as Thevenin equivalent circuit. Thevenin's equivalent circuit. Now here for this circuit, RL is equal to 8 ohm and IL is equal to this current I. Now we need to find VTH and RTH. So to find RTH, turn off all the independent sources. Now when we turn off this independent current source, it will be open circuited, and when we turn off this current source, it will be open circuited. And now to find the value of RTH, we have to remove this RL. So it will be removed from here, and now this will be our RTH. So here we can write RTH is equal to 4 plus 6. 4 plus 6, and this is 10 ohm. So therefore RTH is equal to 10 ohm. Now next step is to find the value of VTH. So here we can write to find VTH, remove RL. Now from here, if we have to find the value of VTH, we have to remove this RL, and now this will be our VTH. This will be positive here and negative here. We have to find this voltage, and this will be our VTH. So let's say this is a node with voltage VTH, and let's say its name is node number. Let's say this is current I1, and let's say this is current I2. Now here this will be node 1 and this will be node 2. So we have to find this node voltage, and let's say this is our reference node or ground node. So apply KCL at node 1. Now according to KCL, that is Kirchhoff's current law, summation of all the current entering a node is equal to summation of all the currents leaving the node. Now here at this node the entering current is only this 6 ampere. So here we can write 6 is equal to, leaving currents are I1 plus 3 ampere. So I1 plus 3 ampere. So here we can write I1 is equal to, I1 will be equal to 6 minus 3. So therefore I1 is equal to 3 ampere. Now let's apply KCL at node V2. Here we can write, let's write here, apply KCL at node 2. Now according to KCL again, summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now here the entering currents are I1 plus 3 ampere. So it will be I1 plus 3 ampere is equal to, I1 plus 3 ampere is equal to I2. Now here we can see, we can find the value of I2. I2 will be equal to, the value of I1 is 3 ampere. So it will be 3 plus 3, 3 plus 3. So therefore I2 is equal to 6 ampere. Now we got the value of I1 and I2. We can find the value of this voltage. So it will be VTH minus, this will be VTH minus, let's say this node voltage is V2 and this node voltage is V1. So it will be, from this I1 we can write I1 is equal to VTH minus V2, VTH minus V2 divided by, here we can write VTH or V1. So both are same. It will be VTH minus V2 divided by 4. The value of I1 is 3 ampere and the value of VTH is unknown, minus V2. Now the value of V2 will be, it will be V2 is equal to this 6 multiplied by I2. So 6 multiplied by I2 divided by 4. Now we can find the value of VTH. So it will be 3 into 4. 3 multiplied by 4 is equal to VTH minus 6 into, the value of I2 is 6 ampere. So if we take this on left side, so it will be 3 into 4, 12, and this will be plus 36 is equal to VTH. So therefore VTH is equal to 12 plus 36. 12 plus 36 is 48. 48 volt is the value of VTH we got. Now we got the value of this VTH, RTH and RL. We can draw Thevenin equivalent circuit. So let's copy it from here and find the value of IL. The value of VTH is 48 volt. 48 volt, and the value of RTH is 10 ohm. So let's write 10 ohm, and the value of RL, the value of RL is 8 ohm. So it will be 8 ohm. If we substitute all the values, it will be 48 divided by RTH value is 10 plus RL value is 8. So this will be 48 divided by 10 plus 8. So it is 2.6 ampere is the value of IL. So IL is equal to 2.6 ampere, but we have to find current I. So IL is equal to I. Here we can see IL is equal to I. So therefore current I is equal to 2.6 ampere. So this is how we can find current I by using Thevenin's theorem. Check the link in the comment section and install the app for free. Thanks for watching. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Thevenin's theorem. Question. Find the value of current I by using Thevenin's theorem. Solution. First of all, let's see the statement of Thevenin's theorem. Thevenin's theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a voltage source VTH in series with resistor RTH, where VTH is the open circuit voltage at the terminals and RTH, this is RTH, RTH is the equivalent resistance at the terminals when all the independent sources are turned off. And this will be our load resistor RL, and this is load current IL. This is called as Thevenin equivalent resistance. This is Thevenin's equivalent circuit, we can say. It is Thevenin's equivalent circuit, and here this IL is equal to VTH divided by RTH plus RL. Now here we can see the value of RL is 3 ohm. So here we can write RL is equal to 3 ohm, and the value of IL value is current I, small current I. Now we need to find the value of VTH and RTH. So let's find the value of RTH. To find RTH, first what we have to do, we have to remove RL and turn off all independent sources. Turn off all the independent sources. Now when we turn off all the independent sources from here, and if we remove this RL, so this will be our RTH, and when we turn off a voltage source, that time it will be short circuited. Here also this is a voltage source, so when we turn off a voltage source, again this will be short circuited. Now here we can see this 1 ohm and this 2 ohm are connected in series, and this 2 ohm is connected in parallel to this, so it will be 3 ohm, or here we can write RTH is equal to 3 ohm parallel with 2 ohm. So it will be 3 multiplied by 2 divided by 3 plus 2. So if we solve, we get RTH is equal to 3 into 2 divided by 3 plus 2. So it is 1.2 ohm is the value of RTH. Now next, let's find the value of VTH. So to find VTH, again what we have to do, we have to remove RL, and here we can write VTH is equal to VOC, that is open circuit voltage will be equal to VTH. So here if we remove this load resistor, now this will be our VTH or V open circuit voltage. Now to find this VTH, first of all let's apply KVL to the outer loop of this circuit. So this is the outer loop, and let's say this is current capital I. Now according to this current I direction, let's assign the sign. This will be positive here, negative here, positive, negative, positive here and negative here. Now let's apply KVL to the outer loop of circuit. Let's say we are starting from this point, so it will be -5, then this will be plus 2i, then plus 1i, means we can write I, then plus 2i, then plus 4. Now here the loop is completed, so it is equal to 0. So this will be 2 plus 1, 3, 3 plus 2, 5. So it will be 5i, and this -5 plus 4 will be -1 is equal to 0. So therefore 5i is equal to 1, and therefore I is equal to 1 by 5. So 1 divided by 5, it is 0.2. So it is 0.2 ampere is the value of current I. Now let's say this is mesh number 1 with current I1, let's say. Now here we will apply. Let's copy this circuit from here. Now let's apply KVL to mesh 1. Let's say we are starting from this point again, so it will be -5, then plus 2i1, then plus 1i1, so plus 1i1, then plus VTH is equal to 0, Now here we can see this I is equal to I1, and the value of I is 0.2. So let's substitute 0.2 here. So it will be -5 plus 2 into 0.2 plus 0.2 plus VTH is equal to 0. Now let's simplify this. So it will be 5 -5, then plus 2 into 0.2, then plus 0.2. So it is minus 4.4 volt. Plus VTH is equal to 0. So therefore VTH is equal to 4.4 volt. So this is how we can find the value of VTH. Now we got the value of VTH and RTH. We can draw Thevenin equivalent circuit. So let's copy it from here, and let's substitute all the values. The value of VTH is 4.4 volt. The value of RTH is 1.2 ohm, and the value of RL is 3 ohm. So it will be of 3 ohm, and the value of IL is current I. So small I, IL, in place of IL we will substitute I. In place of VTH it will be 4.4 divided by RTH value is 1.2, then plus RL value is 3. So if we solve this, we get the value of current I. So 4.4 divided by 1.2 plus 3. So it is 1.047. 1.047 ampere is the value of current I. So I is equal to 1.047 ampere. So this is how we can find the value of current I by using Thevenin's theorem. Check the link in the comment section and install the app for free. Thanks for watching. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Thevenin's theorem. Question: find current through 8 ohm resistance. Here in this circuit, we have to find the current through this 8 ohm resistance by using Thevenin's theorem. Solution: first of all, we will see what is Thevenin's theorem. Thevenin's theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a voltage source VTH in series with a resistor RTH where this VTH is the open circuit voltage at the terminals and this RTH is the equivalent resistance at the terminals when all the independent sources are turned off, and this is the load resistor RL. This is load resistor RL and this is current IL, load current IL. Now we can easily find the value of IL. IL is equal to VTH divided by RTH plus RL. RTH plus RL. And this circuit is called as Thevenin's equivalent circuit. Thevenin's equivalent circuit. Now, first of all, we will find the value of RTH. So, to find RTH, turn off all independent sources. Turn off all independent sources. Now, here we can see in this circuit, we have to find the value of RTH. So, first step is to turn off all the independent sources. Now, when we turn off this voltage source, that time it will be short circuited. Also, we have to remove, here we can write, and remove RL. So, this is the load resistor RL. We have to remove this from here, and now this will be our RTH, that is Thevenin's resistance. So, here we can write RTH is equal to, here we can see this 6 ohm and 10 ohm are connected in parallel. So, it will be 6 ohm parallel with 10 ohm. Now, when we solve this, so it will be 6 into 10 divided by 6 plus 10. 6 into 10 divided by 6 plus 10. So, it is 3.75. 3.75 is the value of RTH. Since it is resistance, so its unit will be ohm. Now, next we have to find the value of VTH. So, to find VTH, first of all remove RL and VOC, that is open circuit voltage, is equal to VTH. Let's copy this circuit once more time. Now here we have to remove this RL and now this will be the open circuit voltage, or we can directly write this will be our VTH. This will be positive here and negative here. So here we have to find this voltage. First of all, we will apply KVL to the outer loop. Let's say this current is current I. Let's say this is a loop with current I. So we will apply KVL to outer loop. Apply KVL to outer loop. Now let's say according to the direction of this current, this will be positive here, negative here, positive, negative. Let's say we are starting from this point, so it will be minus 20, then plus 6I, then plus 20I, plus 10i plus 10i, then plus 12 is equal to 0. Here the loop is completed. So the algebraic sum of all the voltages in a loop is equal to 0. This is called as KVL, that is Kirchhoff's voltage law. Now we can find the value of current I from this equation. So it will be this minus 20 and this plus 12. This will be minus 8 and this will be plus 16i is equal to 0. So 16i is equal to 8. So I is equal to 8 by 16. It is equal to 1 by 2, or we can write it is 0.5 ampere. Now we got the value of current I. Again we will copy this circuit from here. And the value of I is 0.5. Now we will apply KVL to inner loop. Let's say this current is current I1. So here we can write apply KVL to inner loop. Apply KVL to inner loop. Now let's say we are starting from this point, so it will be minus 20, then plus 6i1, then plus VTH is equal to 0. Now here we can see this current I is equal to I1. So here we can write I is equal to I1 is equal to 0.5 ampere here. So here we can write minus 20 plus 6. In place of I1 we will write 0.5, then plus VTH is equal to 0. So therefore VTH is equal to, this will be minus 20 then plus 6 into 0.5. So it is minus 17. If it goes on right side, so it will be plus 17 volt. So this is the value of VTH. Now we got the value of VTH, that is Thevenin's voltage and Thevenin's resistance RTH. So we can draw Thevenin's equivalent circuit. So let's copy this circuit from here. And now let's paste it here. Now substitute the value of VTH. It is 17 volt. And the value of RTH is 3.75 ohm. So it is 3.75 ohm. The value of RL. Here we can see in this question, we have to find the current through 8 ohm resistance. That means this is our RL. So here we can write RL is equal to 8 ohm. Or we can write it here. Here RL is equal to 8 ohm. So RL is equal to 8 ohm. Now we have to find this IL. The value of VTH is 17. The value of RTH is 3.75 plus the value of RL is 8. So this will be 17 divided by 3.75 plus 8. So it is 1.446. 1.446, and since it is current, so its unit will be ampere. So therefore I 8 ohm is equal to IL is equal to 1.446 ampere. So this is how we can find the value of current by using Thevenin's theorem. Check the link in the comment section and install the app for free to get the notes of electrical circuits. Thanks for watching.